This is the screencast for section 3.9, example 5. We're going to use the power rule in all of its power. That's, to me, very deceiving. The power rule is extremely limited. You can only use the power rule when the exponent is a number, is a real number. So you can't use the power rule when there's anything else in the exponent. Only numbers. So an example you may have guessed would apply, but may not have seen before, is this example A here. If y equals x to the square root of 2, then dy dx equals, well, we can use the power rule here because the exponent only is square root 2, so 1 and a little bit. So we'll take square root 2, put that down as a coefficient. The new exponent of x is now square root 2 minus 1. And you can just leave it as that expression, square root 2 minus 1. You don't need to estimate with the decimal. Part B. Looking like we have a little chain rule in this situation. The derivative of 2 plus the sine of 3x to the pi. So I'm going to first deal with the pi on the outside. So I have this expression to an exponent. That's going to be pi. And I'm going to leave the inside alone. So 2 plus sine of 3x. Now to the pi minus 1. I need to multiply by now the derivative of the inside. Derivative of 2 is easy. That's 0. The derivative of the sine of 3x, well, that itself is a composition function, so I need to use the chain rule. Derivative of sine is cosine. I'll leave the inside alone. Now I need to multiply by the inside, which the derivative of 3x is just 3. So I have this whole stringy mess, and I can simplify that to be 3 pi cosine of 3x times the quantity 2 plus the sine of 3x to the pi minus 1. So now try problem number 35. Again, another simple example. Look at the exponent. It's a negative real number. It's irrational, but that's okay. The derivative then, we get to use the power rule, so that's going to be negative square root 2 times x to the negative square root 2, and we're still going to subtract 1 from the exponent. It's not adding 1 this time, you're subtracting 1, which would technically make the absolute value bigger. It's now negative 2 point something, but still. And if you want to rewrite that in a fancier way, or more simplified way, less fancy, would be square root 2 in the numerator, and then x to the square root 2 plus 1 now in the denominator, because you kind of factored out a negative 1 and dropped this x to its exponent in the denominator.